So my name is Jace Powell, and today's topic is zero trust for AI agents. So I got all the buzzwords crammed into one title. A little bit about me before we start. I'm a senior lead engineer with Booz Allen. I work on the cyber physical defense team. So I'm primarily responsible for industrial control systems, operational technology. A lot of our customers are in the Department of Defense, right? So they have kind of all your standard OT stuff, right? They have power, water, wastewater, but they also have some unique cyber physical assets, right? They have space systems, they have weapons platforms, right? So those kind of all fall under my platform at Booz Allen. One project we just kicked off actually recently, we launched basically like an AI server. It's up at the ISS right now, and it's running like this special llama model for the astronauts on the ISS to use. It's been trained on all their manuals and documentation and everything, and just eliminates a lot of the latency and bandwidth issues that you get out in space, right? So we partnered with Meta, NVIDIA, and HPE, and then we were the integrator. So that was a really cool project. This was, I think, last month is when we actually got it up there and operational. So pretty cool thing. My job again, I tend to focus on OT and ICS. Booz Allen is a technology firm. So we do a lot of the technical integrations, engineering. The Venn diagram of OT and AI are kind of starting to overlap more and more, and that's kind of where I fall. Before I got into OT security, I worked in the oil and gas industry for several years. I was an OT asset owner, safety manager, and then made the switch. All right, so I got the talk kind of broken up into three sections. First off, we're going to talk about AI agents, what they are, kind of what they look like today, the direction they're going. From there, we're going to talk about some threats to AI agents, right? The keynote panel kind of touched on a lot of this stuff. And then we'll get into kind of the meat and potatoes of the presentation, which is zero trust, right? How do we secure these AI agent systems? All right, first off, let's talk about what an AI agent actually is. This is one of those nebulous terms, right? There's some marketing influence there. But on one side, right, you'll have people say that an AI agent is a large language model that has, access to data and is able to respond to prompts, right? They'll kind of say that's an agent, and maybe, kind of, right? I mean, that's what a chatbot is, right? I wouldn't call a chatbot an agent, though. Kind of move up the maturity stack a little bit, and people are kind of building what they call agents. They'll use like N8N, which is like kind of like a drag and drop style workflow builder, and they'll chain some LLMs in there, give it some tools here and there. I probably wouldn't call that an agent either, although I don't know. It's definitely debatable. Again, when you talk about what an AI agent actually is we've got some components down here on the bottom. You've got your language model. That language model has ultimately it's context, right? It doesn't matter if it's a prompt, if it's memory, RAG, CAG, right? It's all context and data. But ultimately, what makes an AI agent an agent is that it has agency, right? It's able to think, iterate, make decisions, loop back on itself autonomously, right? These are not pre-planned workflows where we're deciding business logic for the agent, right? Use cases for AI agents, right? We see a lot in software development right now. Cursor, what's the one that OpenAI just bought? Windsurf, thank you. Yeah, those are probably getting the most adoption nowadays. There's customer service chatbots. They'll call them agents, probably more like chatbots, really. But we're really still kind of in the early stages of AI agents, right? We're not seeing them deployed large scale across enterprises, but it's coming. The groundwork is being laid. There's new protocols that are coming out, A-to-A, agent-to-agent protocol. Actually, we'll touch on those in a later slide. I love this graphic. Okay, I found this on Twitter. This kind of talks about the complexity, right? At the bottom, you've got your core model, right? That's just tokens in, tokens out. From there, you have your prompt, right? We're familiar, I'm sure if you're here, you're familiar with prompt engineering, providing context to the language model. From there, the next one up is chains, right? That's kind of what I talked about with workflows, where a lot of times you'll send a prompt to a model, it'll do its thing, it'll produce an output, which serves as the input to another model, right? So again, not really quite an agent. It's more just chains of models. Moving up the stack again, we've got actual agents. These are models and systems that allow these models to act autonomously, take actions, function calling. They're able to use tools. Then at the top we have multi-agent, right? These are, it's interesting. There's different design patterns for this too. Actually, let's just go to the next slide. Actually, no, we won't yet. That's in 2 slides. So we have multi-agents, right? There's agent swarms. A lot of this is kind of conceptual and kind of researchy. But again, there's a lot of money and attention going into this, and it's coming. We're right on the precipice. Let's talk about some of these protocols that are coming out again. So I mentioned A to A, right? This is a protocol that allows 2 agents to interface with each other and kind of perform self-discovery, right? It allows an agent to define what it is, what its scope is, the things it does, what it doesn't do, and really, again, provides context to each agent. MCP, Model Context Protocol, right? This allows an agent to understand how to use a tool, right? I'm sure y'all have seen it, right? Any tool that comes out, API endpoints, integrations, it's real quick and easy to stand up an MCP server. And again, that allows that AI agent to interface with the tool, understand the scope, how to use it, it's pretty cool stuff. It's still in the kind of the early phases. There's a new one that came out, and I just saw this yesterday. I didn't have time to throw a graphic together, but it's called AGUI, which is Agent User Interaction Protocol. So the idea here is this is kind of the interface between an agent and a person. So if I kick an agent off and say, do some research, plan a vacation, right? As that agent's going out and doing its thing, AGUI allows it to kind of bubble up status messages to me, right? You kind of see this in ChatGPT, Claude, Grok. It'll kick back little bits of information. I'm on this stage. I'm on this stage. So that's kind of what AGUI does. And again, this is pretty new protocol. All right, here's that slide. This is from a research paper back in February, and these researchers created they called it an agentic supernet, which sounds like super crazy, right? But essentially, it's individual models as nodes in a large supernet. So here in this graph, each one of these vertical columns that are colored, each agent has a specific function, right? This one's doing chain of thought. This one's doing debate, right? And the idea is that when a prompt comes in, the system's able to activate certain nodes, and these agents can talk to each other and problem solve, basically, right? And it's funny, like this workflow kind of shows left to right, but especially for more complex tasks, right? You can kind of imagine this kind of bouncing around between different agents. Maybe there's the debate node is not happy, so it kicks back to another agent. So pretty cool stuff. The paper claims that it had about an 18% improvement on their benchmarks. So again, I think that's the direction we're headed. Daniel Miessler put it best, I think. He said that right now AI has a plumbing problem in that the models are good, they're competent, they're getting better all the time, but the hard part is wiring them up together and getting them to work and talk properly and really achieve that high fidelity. If I have an agent that I want to book a vacation, I don't trust an AI agent system to book my flights for me, right? That's a pain in the ass if it screws up, right? So we're not at that trust threshold just yet. But if you kind of graph it in your head, right, I think we're on that kind of hard uptick, and it's moving fast. All right, let's talk about threats to these AI agent systems. So first off, these systems are all vulnerable to your traditional styles of vulnerabilities, right? A lot of the ways that we interact with AI agents today are in a web UI, and you still see a lot of cross-site scripting, SQL injection, IDORs. I'll have some examples a little later on, but these are vulnerabilities not only in the web apps but in the models themselves. Kind of like a pseudo IDOR. I've got a good example here in a bit. Prompt injection. I probably should have put that one first because I think it is probably the greatest, represents the greatest attack surface right now. Just untrusted inputs, right? We kind of thought it would be easy to filter those out, and there's some attempts, right? Llama Firewall is a new set of guardrails that came out, and it looks like it's doing pretty good. I haven't had a chance to test it yet, but even still, it's not perfect. A lot of the recommendations you see now are to use regex to block prompt injection, which is just goofy, right? It's not going to work, not at scale. Jailbreaking, again, maybe that falls under prompt injection a bit, but this is forcing the model to do things it's not supposed to do. I think we're all familiar with jailbreaking. Internal data exposure is a big one, right? As organizations are building and training these models, a lot of times they're training on internal data or customer data, right? Or fine-tuning on internal and customer data. And through prompt injection, or sometimes you can just ask it and it spits confidential data out. So again, we'll kind of dive into zero trust stuff in a bit and talk about how to safeguard from some of that stuff. And then finally, it's the Terminator Doomsday scenario, right? Like once these systems really do achieve a level of autonomy, and they kind of have open access to tools and the web, that's where things kind of get a little shady for me. So just kind of buckling up and seeing where things go from here. All right, so here's some cool example attacks. First one, like I mentioned, just ask the model for some data, right? I was working with a model that we have internally for certain purposes, and it's trained on a data set. The data set was not sanitized and properly prepared for the model, and it just kind of spit out things that it shouldn't be spitting out. Data that was not mine, right? Think of it almost like an IDOR, right? Not your traditional IDOR necessarily, but it is an insecure direct object reference, notionally. Next up, right? If we think about how these agent systems are built, if one of the tools it has is the ability to perform, SQL or database lookups, right? Can I inject a SQL injection payload into that? A lot of times you can. As these agents are built into web UIs, can I trick the LLM into responding with basically a cross-site scripting exploit and actually pop up in the web app? It's happened. Again, data leakage. They're number 4. Kind of same thing I mentioned before, right? The next one's kind of interesting, right? So these models have a context window. We found that if you could flood that context window with anything, right? Information, noise, repeated prompts over and over. Sometimes you'll push that system prompt out of the context window, or at least it deprioritizes it enough. It kind of gets lost in the noise to where the developers thought they had guardrails because they got a strong system prompt. Not always the case, though. The last one, I love this one, right? If we're depending on a model to run a shell command for us, right? If we can induce that model to, modify the shell command somehow, essentially have remote code execution on the system, right? So these are just a few examples. Credit to Joseph Thacker. He's a homie. He AI pen tester. He's deep in the weeds on this stuff, and I chatted with him a bit back and forth on it. And this link, I'll put the slides up later if you want them. This link is to his blog on hacking AI agent systems, and it's fantastic. All right, here we go. Zero trust for AI agents. Zero trust. Again, not a term I'm in love with, okay? A lot of marketing hype. Zero trust is not like a thing you can plug in your network and you have zero trust now, right? This graphic is from CISA. They have a zero trust maturity model. So they've gone through and kind of defined these 5 pillars: identity, devices, networks, applications, workloads, and data. And then they have these 3 cross-cutting sections here: visibility and analytics, automation, orchestration, and governance. Basically, the idea with zero trust, the tenet is that we're going to assume the system is breached. We're going to assume there's an attacker on the wire. How do we secure the system from the inside so that if an attacker is there, they're restricted, they can't do much, we're going to minimize their impacts. And that's kind of the idea. So I'm not going to go into this, but CISA also defines maturity levels for zero trust. There's traditional, which is not zero trust, right? These are manual security processes, maybe non-existent security processes. Moving up, you've got advanced. This is where you start to get into some zero trust controls. Maybe you're mapping to some pillars here. But not a whole lot of automation, right? Maybe we just have some security controls in place, and we're starting that journey. And then optimal, right? This is where we want to be. This is basically continuous identity and device authentication and authorization across every interaction of the system. All right, let's go to the identity pillar, and I just lost video. Oh, that HDMI came out. Perfect. Okay, identity pillar. So I'm going to fly through these. I'm not going to hit all of them. When it comes to AI agents, a big core tenet of the identity pillar is managing your non-human identities, or NHIs, right? So when we're talking about agents using tools, right? Those agents need to have the same security controls that a person should have, right? When those agents are interacting with each other, right? We need to have authentication between these 2 agents to understand that, this agent is only supposed to talk to this agent or this system, and vice versa. Those identities should be stored in some kind of an identity store, whatever that looks like. There's a ton of products out there. I think I even saw a vendor or 2 here over in the main stage area that handles identities. Again, nothing new under the sun here. RBAC, ABAC, fantastic tools. I'm going to go through these. We do this every time. I was talking with Tony about this earlier. We do this every time, right? The industry builds something, comes out with something new, and we rush to build it, and it's done, and we're like, oh shit, we got to secure this thing. We forgot to do that, right? And that's kind of where we're at now. Is organizations they're in a rush to first to market. We're AI native company, or we're building internal AI tools for us, right? Because we need to do things better and faster and cheaper. But again, we get it done, or we get to a point and we come up for air and we realize that we forgot to do a lot of this stuff. A big one here: visibility and analytics. Monitor and log your agent actions. You need to understand what these agents are doing. So again, as we're building these applications, these things have to be logged, and not just logged, but monitored and alerted on, right? We need to understand if agents are doing things outside of what they should be doing. I'm not going to touch on the rest of this again. There's a ton of stuff here. Next pillar is devices, right? This refers to the servers and the assets that AI is using and interacting with. Nothing new here, man. It's security policies, right? They should exist. You should have them. Device threat protection. Okay, again, a big one. These servers should have EDR, right? If there is a prompt injection exploitation and there's some kind of remote code execution, we need to understand what happened and be able to alert and respond, detect, alert, and respond to it. Governance, I kind of skipped over that earlier. This is one of those cross-cutting capabilities, right? You should have governance across each one of these pillars, right? Governance gives you the teeth to do these security controls. And a lot of times, if you start with governance, that gives you the permission and the ability to implement these security controls. So definitely a big fan of that. It's not the most exciting work, but it does move the needle. I think of governance as the baseline, okay? We have, good policies, right? You've heard like compliance is not security. I don't know, agree, disagree, maybe. I think of it as, this is the baseline for our security program. And again, though, the goal should be to exceed some of that, right? And then over time, as we improve, our baselines improve, and again, we're on this zero trust maturity journey, as CISA calls it. Networks, a great tool. Micro-segmentation, right? Even macro-segmentation is good, right? But these AI agent systems should not be accessible outside of routes that are predefined. End-to-end encryption, nothing new. But again, there was anybody here for the last talk? There's a developer in here, and they were talking about how they're building some mobile apps and putting in basically logging things, secrets and things like that. And then they said, yeah, hopefully at the end I remember to take those lines of code out that log things, right? Kind of seeing that a lot now with these AI applications that are being built and deployed too. Is things are done, it works, push it production, and move on. Applications and workloads. This is a big one. So, we're talking about maturity levels, right? Kind of the highest maturity level is a system where there's kind of these, dynamic access controls, right? You have continuous authentication, so you have AI agents that need to use a tool, right? They don't just have a hard-coded API key sitting somewhere, right? They have the ability to basically continuously authenticate, right? For each tool call, they need to get a session token, yada, yada, yada. There's tons of tools out there that do this kind of stuff. Okta, so on and so forth. Secure application development and deployments, right? CI/CD with secure coding practices. Software bill of materials, right? Do I know what components are going into these AI agent systems? Am I just grabbing, or are my developers just grabbing some random cool project that came up on GitHub trending and hey, yeah, this works, let's push it in production. And yeah, lo and behold, it's kind of a pile of you know what. It happens. Okay, I love this one too. Visibility analytics. Monitor AI agent workflows, including chain of thought. Right. So we got these reasoning models a year ago or so, where they kind of have this chain of thought process built in. I think the first, if not the first, then one of the first was OpenAI. Right. They had a reasoning model. But it kind of made me upset because they obfuscated the chain of thought. So you couldn't actually see what the agent was actually thinking and actually doing. It would happen behind the scenes, and they would kind of summarize that chain of thought, and they give you, this is a summary of what the agent's thinking and doing. I think the first one that actually gave you the raw chain of thought was the DeepSeek R1 model, the Chinese model, right? Which was great because you could actually see, this thing is, it's breaking down the prompt into, first principles. It's debating with itself. There was some red team testing for one of the OpenAI models, and they saw in that chain of thought that these models were kind of debating, like almost doing or considering immoral things, right? Like the user's asking for this. I could do this. Should I do this? It's really interesting to see how these models think and work. But again, right? If possible, and it should be possible, I want that chain of thought I want to be able to debug it, right? Using that chain of thought to understand what's this model actually trying to do, right? And then from there too, that allows me to build security detections, right? If I want to detect prompt engineering, I need to see that chain of thought to actually understand, what's kind of going through that model's head. Data. Okay, I think this is the last pillar. Obviously, data is huge. Again, I keep saying this is nothing new. The concepts are not new, right? The application to AI agents and AI systems is new. I mentioned earlier, understanding what data is used to train and fine-tune my models, not just understanding, but ensuring that that data is compliant with what I'm supposed to be doing is huge. Not only that, not only the data going into the models, but also the data that the models are accessing. I can't just give it read access to my production database, right? I probably do need to scope down things quite a bit if possible. Touched on data access, encryption, right? That's stuff we should be doing. I feel like we're in a pretty good state there nowadays on the stuff I've seen. All right, security controls, guardrails. Again, a marketing term that I don't like because it means different things to different people. Guardrails is the name of a GitHub project. It's the name of a commercial solution, and then it's kind of this this conceptual idea, right? So when I say guardrails, this is what I mean. Number one, content filtering. Again, understanding and blocking, or at least alerting on prompt injection attempts. I need to understand what's coming into my model, but I also need to understand what's going out of my model, right? Is this thing outputting things that it shouldn't be outputting? Again, another plugin for Llama Firewall. I saw some demos. It looks pretty cool. I want to kick the tires on a little bit more, but it looks like it does have the ability to monitor and block unwanted outputs, right? Again, which is super valuable because you can kind of control things on both sides of these systems. Next up, access and controls, access and usage controls, right? So again, touching on auth, right? Is this thing allowed to use this tool? How is it allowed to use this tool? What are the inputs? What are the endpoints it's allowed to touch and use? Things like that. Next up under guardrails is monitoring and auditing. So again, like understanding what these systems are doing, monitoring and alerting on anomalies, and really just trying to achieve full visibility in these systems. Observability, again, I'm not going to touch on that. Just did. Behavioral constraints, right? But talked about governance. I should have policies for, or at least SOPs for what these systems are doing and are allowed to do. And then data governance, right? That's the last pillar, right? We need these things. All these I would consider to be a set of guardrails, right? These are kind of your number one security controls for AI agent systems. And then finally, another hot term, secure by design. Again, we build these systems, they're done, then we say, oh shit, we need to secure them. So again, I'll just touch on these real quick because there's a launch happening shortly and I'm sure y'all want to make it. Least privilege architecture, right? This is just kind of standard AppSec stuff, a lot of it. A big one, isolated execution environments, right? If I can containerize these systems, maybe there's exploitation attempt, but we can restrict the lateral movement opportunities, or at least make it a lot harder for adversaries to pivot out. Tool call security down near the bottom, right? Need to understand what agents are allowed to do, what systems are allowed to touch, validating the inputs and outputs, and then blocking misuse. And then finally, SDLC, right? Kind of the full gambit of everything involved in SDLC. I'm not going to touch on that too much. There we go. That's all there is to it. 5 pillars. All right, thank you.